Hi everybody, my name is Emily Hernandez and I'm in Ms.Cyrs class Math 115 from 2 to 250. And today's video is going to be about zero, negative, and fractional exponents. So some rules to know before we could actually start to these problems. If you look in the blue boxes, on the bottom blue box you'll see a basic format, which is a to the n. So the a would be the base, and then n would be the exponent or power. And then what basically a to the nth power is how many times you have to multiply the number by itself. So for example, if you have a to the third power, it would be a times a times a. Some other rules, if you have a multiplying sign, so a to the m power times a to the n power, it would be a to the power of m plus n, so you'd be adding the exponents. And if you have parentheses a to the m power, close the parentheses, to the nth power, you'd basically be multiplying them, so it'd be a to the power of m times n. And then if you see a division sign in there, a to the m power over a to the n power, you would be subtracting the exponents, so it would be a to the power of m minus n, so it would be m minus n. And then sometimes you'll get a negative exponent, so it would be a to the negative n power, but you don't want a negative exponent, so you would have to do 1 over a to the n. You would bring it up or you bring it down to get rid of the negative. And then if you have a to the 0 power, it's always going to be 1. Anything to the 0 power is always 1. And then moving on to properties of radicals, if you look to the right, you will see something called flower power. So if you ever see, for example, a to the power of m over n, m over n, you can think of it as flower power. M is the flower, and then n is the root, which is basically power root. So the root's always going to be on the bottom, like in the ground or the denominator, and then m, the flower power, is going to be the numerator. So basically, if you put that in radical form, n is always the root, and then m is the power. And then, as you can recall from the beginning, it's either what you always want with the base is the power or the exponent. So m is always going to be with the base. And then on the side, you could see to the left some properties that you should know to get these problems. I'll give you a minute to look over them. For number 4, if n is ever an odd number, it's just going to equal a. And then if it's ever an even number, it's the absolute value of a. I forgot to write the absolute value. So just remember, if it's ever an even number, even if it's a negative, absolute value always throws everything away, and it's just the base. It's always a positive. It's always going to be a positive number. Just remember that. So moving on to the first problem, it says to simplify the following expressions, assume all variables represent positive numbers. So right here we have x squared all over a to negative squared b squared, and then you multiply that by negative 3 exponent. So basically you want to distribute or multiply each variable, each exponent by negative 3. So you would end up with x to the negative 6th power all over a to the 6th power b negative 6th power. But then again, as you recall, we don't want negative exponents. I made a mistake there. It's supposed to say exponents, not variables. So you would flip them, which would become b to the 6th power all over x to the 6th power, a to the 6th power. And then for b, again, we want to simplify, and then all positive numbers. So then you'll have 3 square root of 18 minus 4 square root of 50. Basically, you want to get anything inside the square root, you want to factor, you want to find the prime numbers. So I did a factor tree because that helps me the most. So you want to factor it all the way out, and then you'll be left with my second equation, which is 3 to square root of 2 times 3 times 3 minus 4 square root 5 times 5 times 2. And then if you always want to look at the root, because that will tell you how many of one prime number you need to be able to take it out. And if it doesn't have a number, it's always going to be 2 unless stated otherwise. So in this case, it's a 2. So then if we look at the first square root, we can see that you have 2 numbers of 3. So you can take that out of the square root. And then on the other one, you have 2 numbers of 5. So you can take that out. So you'll be left with 3 times 3 to the square root of 2 minus 4 times 5 to the square root of 2. And then you combine like terms. So you do 3 times 3 minus 4 times 5, which is negative 11. And then you'll have a square root of 2. And the final answer would be negative 11 to the square root of 2. So moving on to the last question. Again, it says to simplify and assume all variables represent positive numbers. So for this problem, it's cube root of 54x to the 5th power and y 6th power. So then you want to get all exponents and variables to its prime number slash factor. So then you want to start with the 54. So you want to factor that out as much as possible. The same thing with x and then y. For the x, you would just the easiest way for me is to write out all the x's, and then since it's a cubed circle, the groups, and then take that out of the cube root. So for the 54, I'm left with 2 times 3 times 3 times 3. I can take out the number 3 because it was there 3 times. And then for the x, I could take one group of x, and then for the y, I could take out 2 groups of y. So the final answer I got was 3x to the y squared, cube root of 2x squared. And then you always want to check if you can factor any more. And in this case, you can't. So the final answer is 3x y squared to cube root 2x squared. So this is it for this video. I know it's a little confusing at first, but if you keep practicing and getting more questions, it will get easier as you practice. Thank you.